Welcome to this webinar, Unlocking Direct Current, Simplifying DC Power with CurrentOS. We are thrilled to have you with us today. We have our famous hosts today are Dr. Tong Cheng, who is VP of Overseas Market for Winline Technology. Elan Meng, she is the Global Strategy and Thought Leadership Leader at Schneider Electric. And Yannick, who is president of CurrentOS. So Winline Technology and Schneider Electric are valued partner of CurrentOS. I am Raphaël Raymond, in charge of marketing activities. And we also have Prashant Kurup, who is the General Secretary of CurrentOS. So before we dive in, I have a few housekeeping information to share with you all. So this webinar will start with a presentation. We will be presenting various information about CurrentOS. So feel free to ask any question in the chat. We have set aside plenty of time after the presentation to address your questions and have a discussion. And of course, this webinar is being recorded. So if you have any need to receive it by email, we will share with everyone. We will also post the recording on LinkedIn and on our YouTube channel once we are finished today. And finally, your camera's recording may be turned on or off. So when you ask questions in the chat, feel free to turn on the camera if you want to participate. Today, we are also happy to invite you to join us on LinkedIn and YouTube to follow our news, to get connected with the vibrant DC community of CurrentOS. And now, without further ado, over to our host. So, Tong, let's begin with you.
Yeah, hello, everyone. So this is the first question maybe everybody want to ask. Why was CurrentOS created? And then for what benefits?
Yeah, thanks, Dr. Cheng. So our world is electrifying towards direct current power. And today we're already living in the DC world. DC is poised to play a very key role, as highlighted by IEC in one of its reports, saying that direct current is a disruptive technology that fundamentally accelerates energy access and improved energy efficiency. There are clear signs showing that the DC ecosystem has established. From the renewable energy sources side, most are naturally inclined towards DC generation, like solar panels, like fuel cells, and also battery energy storage system. Then, if you take a look around us, we are actually witnessing a surge of the development of DC products from the load side as well, including electrical vehicles, consumer electronics, LED lighting and display, and appliances use, the variable speed drives, which operates actually with internal DC bus as well, like heat pump, HVAC, air conditioner. And any device with a battery is also DC ready as well. Okay, so with that said, the trend is that the electrical distribution is evolving towards DC. So CurrentOS was established. CurrentOS is this global partnership of manufacturers and electricity stakeholders leading the research and innovation to shape DC standard that enables partners to develop DC certified products or services for the construction of DC installations, of course, including DCMicrogrids. This initiative promotes electrical safety, energy resilience, and energy transition. Among the partners, as you can see here, we have industry leaders like ABB, Eaton, Schneider, Mersen, Tridonic, and UL Solutions managing the board of CurrentOS. Then we have very diversified representation from manufacturers and electrical integrators, universities, certification companies, or even trade groups, ensuring a comprehensive approach to address industry challenges. In terms of geography, CurrentOS partners span across the globe with a presence in North America, Europe, and Asia Pacific, enabling CurrentOS to leverage diverse perspectives and address, global challenges effectively. If you zoom in Asia Pacific, we also have very diversified partners joining already. I will not call out all of them, but you can see partner names like Winline, Hisense, Infi Power, Daikin, or Xi'an Jiaotong University, Isha Foundation, and so on and so forth. APAC is definitely a very strong and innovative market with, a bold government and policy push, and very strong technology-driven industry players as well. So together with CurrentOS, we would be able to develop APAC market and the whole DC world as well. Then I give the floor to Yannick, our CurrentOS president, to briefly talk about the implementation of DCMicrogrids. Yannick?
Thank you very much, Elan. So hello again, everyone. So one of the very important aspects of CurrentOS is to learn with real cases, to learn with hands-on. So you can see on this slide a snapshot of some of our existing and active pilot projects. We will go deeper next with some projects implemented in China. But I want to highlight a few others that are implemented around the globe. So we have a DC microgrid with a charging infrastructure for electrical vehicle in North Carolina in the USA. We have had from 2017 a commercial building named Circle Building with meeting rooms and a restaurant inside. So it's not a lab, it's open to the public, going in and out as they want. From 2017. N470 road is a critical infrastructure in the Netherlands, a 5-kilometer motorway powered with PV panels, batteries, and powering the light system on the traffic light. So it's a very critical infrastructure powered with DC, accessible to the public day after day. We have also in the Middle East some residential housing, full in DC with PV and battery powering the houses. I want also to highlight one application. I will not highlight them all, but in the UK, we have a hospital where the HVAC system is powered by the PV, okay, with a maximization of the use of the power from the PV. And I will not list them all. All are very interesting, but I just want to give one last word on the EV charging park we have in Grenoble, France. This one has a bigger power than the connection to the public grid. And this is only achievable in DC. So one of the very important benefits of DC. Now let's dive in the Wuhan installation. Over to you, Elan.
Thank you very much, Yannick. So I invite everyone to have a virtual visit in our Wuhan plant in China here, built up by Schneider Electric. So by end of 2023, Schneider Electric completed this real case project with hybrid AC/DC architecture. The total installed capacity of the rooftop PV system is about 900 kW peak, covering area of 20,000 square meters, and also a 48 kWh battery storage system. The system includes a 100 kW bi-directional interlink converter cabinet, a DC electrical equipment with the distribution and also solid-state circuit breaker protection, and the monitoring system. On the load side, the system covers a DC air conditioners, DC street lights in the parking, DC bi-directional chargers, as well as the DC lighting and 48-volt DC USB-C sockets indoor for meeting rooms, exhibition halls, and pantries. Okay, so let's go to a brief review of the DC topology. It's a grid-connected system, so AC power supply is connected to the container and actually connected to the interlink converter, change from AC to DC. So the bus running as the backbone is the DC 700 volt. The sources and loads are connected to the DC backbone. As you can see here, we have lighting, USB-C socket, street lights are powered through DC-DC conversion. And then we have PV bus and EV chargers are also connected to the DC bus. For some of the AC essential loads, we use DC to AC conversion to power them as well. Okay, then through a complete DC product solution and a autopilot system, if you will, without centralized control, this solution achieves flexibility at the system level. So key loads, such as the newly added EV chargers, are 100% powered by green energy, such as solar. And combined with the existing PV power generation, the system helps the entire factory reduce the carbon emission by 577 tons per year, thereby reducing the annual carbon emission by 13%. In terms of system design, this solution is highly scalable and flexible. It is able to be adapted according to the load requirement. And because the system prioritizes local consumption, so the DC on-site generated power is consumed by DC loads. Thus, the conversion loss is also optimized. So much for the Wuhan plant deep dive. I'd like to turn to Yannick again to summarize the key benefits of the DC with CurrentOS. Yannick, you're
muted.
Sorry. Yes, thank you, Elan. I wanted to highlight that we are still learning, okay? DC is new. We learn by every pilot, we learn something new. But we start to have some ideas of very strong benefit of DC. One very popular is efficiency. It's written in a lot of academic paper, proven. However, this will only be, I would say, a game changer for very special application where there is a lot of issues with the conversion losses, or there is a need for regenerative braking and recover the energy from the slowdown of motors. However, the three next benefits are very strong, are quite unique with the DC. I mentioned before with the EV charging installation in Grenoble that DC systems can support a higher installed power than the public grid connection. That's huge because in case in a country you have limitation with your power grid to get all the power needed for a new investment, you can have a local system that is bigger than the delivery substation. The third benefit is the seamless transition. In case of public grid failure, there will be no power cut. The DC system will continue without any voltage dip or even voltage blackout for a moment. Obviously, the system will adapt to the power available, and that's one of the huge benefits of the DC system we propose with CurrentOS. However, the business continuity will be ensured. And when the power grid is back, the transition will be seamless as well. So this is a super strong benefit in areas where the public grid might be less and less reliable due to overload, due to all these EV charging infrastructure, all these data centers, all these new heat pumps, changing the heating system. So having a more resilient system is super important. And last but not least, we speak about power efficiency. So you already know energy efficiency, so the savings on your energy bill in terms of kilowatt hours, but power efficiency are how efficient you can be in power demand on the public grid. And thanks to the DC installation, we can lower the power peaks and reduce the injection on the public grid. That help to maximize the self-consumption, and it also helps the stability of the grid. And this is not small. We have demonstrated a reduction in the power demand by 3 to 5 we divide by 3 to 5 the power demand on the grid. So this is a huge benefit for the future. Now I hand over to Dr. Tong.
Yeah, so the question is which rules allow the CurrentOS to deliver these benefits?
Yeah, thanks very much, Dr. Tong. So there are 4 key considerations from CurrentOS's technical decisions. First is that to address DC safety concerns, because safety perception remains a significant challenge with the direct current, as many electricians are cautious about adopting it. Demonstrating that today's technology has already resolved the DC safety concerns is crucial for its widespread acceptance. And secondly, creating a multi-vendor system. Today, there are already some manufacturers offering microgrid solutions, but these are often closed source or single branded, if you will. This means that PV converters, battery chargers, or even AC/DC converters, they should from same brand, because if they are from different brands, they cannot interoperate. But CurrentOS aims to create a truly open ecosystem where products from different brands can work seamlessly together. And thirdly, making DC installations simple for any professionals. DC must be accessible and easily scalable to all the industry players, from design offices to installers. So DCMicrogrids should be easy to expand. In AC systems, extending a microgrid setup is very complex, but CurrentOS seeks to simplify this process, leveraging DC to provide scalable and flexible solutions. Finally, just as Yannick mentioned, that DC is taking energy resilience to a non-sea level, solving the new challenges of the distributed energy resources. In AC systems, like Yannick mentioned, that it's optimized for consuming energy from the public grid. However, when you become complex, when local energy resources are involved, AC is complicated. We know, for example, switching from public grid to a genset, you need the automatic transfer switch, so ATS. But when we develop local energy resources, we have to combine multiple, solar panels. It could be from the rooftops or in the parking lots. Physically, it's different. And also with distributed battery storage, and even EV batteries can become the backup power. So we are not talking about 2 sources, but multiple. The complexity is increasing, and AC systems struggle to address those complexity. And CurrentOS aims to resolve those issues with the DC systems and facilitating seamless integration of the DER, distributed energy resources. To enable and realize those drivers, on the right-hand side, you could see that the core technical principles CurrentOS defines. I won't go deep into each point, but please understand that together with all the partners, CurrentOS is setting up the rules to make DC work at all the aspects, including like voltage bands, distributed control scheme, protection, earthing scheme, so on and so forth. If you are interested in technical topics and CurrentOS working group details, I recommend you to stay tuned with our future webinars as well. Okay, then let's go to the next slide with Dr. Cheng Tong to check the details of one of the Winline's installation. I hand over to you.
Thank you. So here, previously, Elan has already showed a project in Wuhan, and then now we will share a real project in Jordan, which was built by Winline with the DCMicrogrid system. So the Jordan this project showcased a DC-based microgrid system, and then it brings together the solar panel and then battery storage and the EV charging station. It's located in Jordan. Jordan is a country blessed with plenty of sunshine, making the project is perfect to integrate the PV panel. And with such abundant solar resources, the project really maximizes the renewable energy generation and then demonstrate the full potential of a solar-powered DC microgrid. So from this picture on the left side, you will see the very basic topology of the whole microgrid system. And then we also want to share some key figures. Like the whole solar capacity is 180 kilowatts. And then the energy storage is 120 kilowatts and then 215 kilowatts hour. And then the whole, the most important here is we want to highlight the efficiency save. We compared if we use this as a AC microgrid, and then the whole efficiency will be 82.87%. But when we adapt to the DC microgrid, the whole efficiency increased up to 85.49%. And then the efficiency gain is reached up to 2.6%. And then we also did a investment payback calculation. Within 3 years, you will gain all the investment back. And then after the third year, you started to get the profits from this DC microgrid system. And then, so meanwhile, the system also include a real-time monitoring interface for managing operations and equipped performance. In a summary, this project is a great example of how DC microgrids can boost energy efficiency, support renewable integration, and then deliver the real economic benefits. As Yannick mentioned, for the DC, we just started and then we are learning. This is only the first project Winline launched in Jordan. We also have another project launched in Australia with 2 megawatts DC charging station system for the megawatts charging for the heavy-duty trucks. And then meanwhile, in Europe, we are also planning for the future with the data center projects. So all this in summary, for the DC, we consider it is not only the PV panel and then charging station. We believe with the data center business involved, it will be a new challenge and then the energy revolution in the future. Yeah, so thank you for sharing this case from us. And then I hand over to Elan for the next question.
Thanks. Also, Dr. Cheng, could you please also share with us why Winline joined CurrentOS? What's in it for Winline? And then if other partners would like to join as well, how to carry on the process?
Yeah, so it's a very, very good question. Why Winline joined the CurrentOS? As I just mentioned from the previous project, first, we recognize how important of DC technology is. It's really becoming the backbone of the future power distribution and energy efficiency. And then the second, we also want to stay aligned with global standard and best practices. Now with the globalization, China is not a single player, Europe is not a single player, and in the US the same. We keep close to the DC developments in Europe, North American, Asian Pacific, and adapting the CurrentOS, a lot of technical information, for example, the droop control solution. That is something already being requested in many of our projects globally. So align with the standards is also very important for us, not only within China, but globally. And then the third is connecting with the industrial partners. Join the CurrentOS give us a great opportunity to contact with other leading DC innovators and strengthen our partnership across whole Europe and then American and also the Asian Pacific area. It's a very, very good experience for us. And yeah, if we go to detail how to join the CurrentOS, there are a few ways to get involved. But generally, is if you are first, it welcomes the space facers and the developers, professionals, and then researcher labs and organizations who are actively promoting the use of the DC technologies are all welcome to join the CurrentOS. And then it's also open to manufacturers. Specifically, these are developing products that allow energy management and safety guidelines for the DC devices and the applications. So generally, if you are helping to advance DC systems, doesn't matter through design, development, or manufacturing, this is definitely a place for all the partners to join the CurrentOS partner program. And then also for the manufacturing, there are 3 main categories to choose. For the bronzer or the silver or the gold category for different size of the companies and the groups. It's a very good choice for all standard of the companies. Okay.
Thank you all for this very dense and very rich information session on CurrentOS. Now we have a Q&A time, and we have a few questions already in the chat that I will start picking up with. So we have a first question of Ramaratham, who wrote, instead of 48 volt DC, the focus should be on 350 volt DC. High power appliances like HVAC, cold storage, pumps, etc. are better run from 320 DC or 230 volt AC. No power conversion in this. We have implemented such system in India. So thank you for sharing this. Who would like to answer or discuss with Ramatham on this topic? I can also open the mic for him so he can share his comment live. Who would like to pick up on this question?
I made a small comment in the chat, but definitely CurrentOS has documented 350 and 700 volt. 48 volt exists for decades. There is no real need to detail a lot of electrical rules around the 48 volts. So this is why CurrentOS focused exactly on 350 and 700. 350 is a natural replacer of the 230 volt AC, and 700 volt will be used to replace three-phase 400 volt AC. There are variations and different systems used around the planet. In China, it's usually named 750 volts, while CurrentOS named it 700. In CurrentOS, we use a droop control, as Dr. Tong mentioned, and it's super highly valuable way to stabilize microgrid and control the microgrid. So we need a little more, I would say, voltage variation possibility to allow the droop control. So this is why we named the system 700 volt. But in this system, the voltage can fluctuate between 640 and 780 volt. So it's already a wide system, and we can always, I would say, have software settings to rise a little bit the voltage up to something like 800 volts. So it's a very open and flexible solution. And I've seen, Raphael, the question about RCDs. So definitely, we have residual current protection devices available for DC systems. Yes.
Does that answer to your question, Ramada? We can have you on stage if you would like to discuss it live. Oh, yes, I see you joining. Yes.
Hello.
Yes, please.
Go ahead.
Would you like to discuss further? Yes.
Yes. Good morning. Good morning, everybody. I'm happy that Yannick has clarified the point. I'm also aware of that. In fact, both the other eMerge Alliance and IEC also adopted the similar standard 350 volts, and we work extensively on the 350 volt thing. Only we have some difficulty in getting RCDs for this. That is only issue, but we are managing it, some imports and all these things. Thank you.
Thank you for the sharing. And I would have to say that, yes, CurrentOS is this alliance to develop the rules and for us manufacturers to work on, further developing the products. And thank you for the sharing that it's very difficult for you to find the right RCD. And we need to, further look into that. I mean, Schneider, Elan, ABB, all of us. Yes. Thanks for sharing.
Thank you.
Okay, thank you. We had another question from Karen. So I don't know if you want to elaborate further on the stage. Karen, I invited you to join us, if you would like. So the question was about why 750 DC volt is commonly used for DC systems in China. So who would like to pick up on this? Elan or Yannick or Dr. Tong?
Okay.
On this question from Karen?
Hello.
Yes, can you hear me?
Karen is not going to join us anyway. So my understanding is 750 volt DC is somehow proposed by one of the local DC alliance in China, and but to be honest, CurrentOS right now is also having some, good relationship with this DC alliance, signing MOU, and there's going to be a, let's say, global summit with the DC alliances to have everybody sitting, around the table to have an open discussion on this point. But yes, indeed, Yannick just mentioned, 750 volt DC today is proposed by China.
And again, one single
yes
750 or 700 is just a label to identify the system. You need to go deeper and have the value of the permanent mean, permanent max, how it fluctuates in between, what is so you will find in CurrentOS a definition that is very extensive of the voltage. We define 7 bands, 6 voltage value, which helps to really specify the product and design the system.
Okay, very well, thank you. So we have a next question from Amit.
Sorry, I will have just one last thing.
Please.
700 volt loads. The 700 volt compliant loads of CurrentOS are compatible with the 750 volt system as designed in China.
So I don't know if Karen wanted to interact. You say she's not here. I don't see her joining. We have another question from Amit. Amit, I invited you on stage also if you would like to interact. So his question was, what is the maximum DC being used in data centers, and is it supported by the DC bus duct?
Okay, so usually data centers try to have a little higher voltage. They try to operate around 800 volts to minimize the losses. But we need to know that data centers are with a specific application with highly skilled engineers making a fine-tuning on the values. So we can definitely, again, use the same loads and the same source to power a data center at 800 volts. But in CurrentOS, we have documented a solution that is easy to implement and easy to design for commercial building, where you don't need to have, I would say, years of training to make it happen. And then super specialists will be able to fine tune and maybe change a little bit the voltage for a data center.
Amit, does that answer to your question? Would you like to elaborate further or interact with our other hosts? I I don't see him joining. We have another question here from Anthony. The question is, what practical applications could this technology have within data centers environment? And we have a webinar on that topic coming very soon. What impact might it have on their design or operation? Are there any existing or planned projects demonstrating this implementation? Yannick, I think you are the one for this question.
Well, definitely. Well, DC in data center is not something new. Huh? The acceleration of semiconductor protection make it now safe and easy to implement. So more and more data center companies are exploring the power in DC, and we are working CurrentOS, working together with OCP, the Open Compute project, to define this kind of solution.
Anthony, would you like to ask your question or elaborate further on this live? Please join us on stage. Otherwise, I'll move to the next question. We have a lot of questions coming up. Taosha is asking what DC protection protocols exist now and what to expect in the future. Who would like to pick up on this?
Maybe I can take it. So of course, DC protection could be very different from AC, but still with existing technology, traditional ways, we can have still fuse working in DC protection, and even traditional electromechanical kind of breaker will work in DC protection, but under some condition. And then in the future, you can foresee with the new technology come into the place, and then you can foresee the power electronics components cost will decrease. Then definitely we're talking about solid state kind of protection. And for your information, CurrentOS is have a full scheme of such kind of protection, when to use what kind of protection, and also it means this zone is under which level of protection. They have very detailed research around this topic. So I hope I answered your question, Taosha. Yeah.
If you want to elaborate further, please join the stage. I invited you.
If I just add one word on the protection.
Yes.
The concern of safety for DC has to do with protection, and the go around is to go for semiconductor protection. With AC faults are much faster than AC faults, something like 10,000 faster because of the capacitor discharge. So semiconductor protection is the right way to make DC microgrids safe. And this is fully documented with CurrentOS.
Yes.
Okay. And we can also have a future webinar on that. We will have a short poll after the Q&A session to decide on future webinar topics. So it could be an option.
And by the way, this also answers the question of Shafquat. Efforts for arc flash. When you have semiconductor protection, you have no more arc flash. So this is the best way to avoid calculation on arc flash.
Would you like to elaborate on your question, Shafquat? You're welcome on stage. I invited you. Okay, I don't see any new question. As I just mentioned, if you have more questions, please pop them in the chat. We would like to propose a poll so that we can decide on our future webinar. We have, add new, yes, yeah. Here I come. So we have been thinking of several webinar ideas for our future sessions, and we would like you to tell us in the chat which one would be your favorite, or if all of them are interested, which one would you like first? You can just write 1, 2, 3, 4, 5 in the chat to
yeah. But sorry, Raphael, there is another question asking about the development.
Let's go with the poll, and we will revert back to the question right after, since I have this on screen now. So please pop in the chat your preferences. I will also add them in the poll feature.
Do we answer the poll in the chat? Yes.
Yes, I am. Sorry, it didn't come along this session. I am adding it now. It will show up in a few questions. In a few moments. Sorry. And voltage. So I am sharing the poll now. Can you see it on the right-hand side of your screen? And everyone will be able to vote. So it's just an order of preference. We will probably cover all topics, but let's tell us with which one you want us to start next time. Next time we have a webinar. So there is a very popular request for electrical protection. It's a great, it's a very essential topic, of course. So as you keep on answering, okay, so we have a very, very urgent topic for our next webinar about mastering electrical protection. Thanks for your vote. You can keep voting. I will go back to the chat, to the new protection. We have a question from Fang. Which direction will the TN system develop in the future? Positive grounding or negative grounding? Who would like to pick up on this one?
So it has been demonstrated that negative grounding, meaning that you have a live conductor positive and you have a friendly conductor 0 volt negative, is safer. The effect on human body is lower. So for commercial applications where you have unskilled people entering the buildings, we will probably go for, well, we recommend negative grounding, okay? Positive grounding, as far as I know, is mainly used in some PV farms. So it's an area that is restricted access and only accredited people can go in. So that's a bit specific.
You want to ask further question on this? I will invite you on stage. You would like to interact, confirm with our hosts?
Maybe one more word on this. Even if we prefer to ground the negative conductor, we can still have bipolar solutions. We can still have symmetrical solutions. And I mentioned earlier the N470 road application. Here we have a plus and a minus 350 volt distribution for the lighting poles. So we can have also a bipolar system with a midpoint grounding.
Okay, at this stage, I see no more question in the chat. Does anyone want to share another testimony or another feedback on DC microgrid? Yannick, do you want to elaborate maybe further on any CurrentOS hot topic, the new work we are working on now?
Yes, we are working on many things. Maybe before I enter this, special thanks to Lisa Chi from Jiaotong University, from Xi'an Jiaotong University, who helped us to organize this webinar, and also to mention that in Xi'an we will have the international conference on DC microgrid next year in June. It's a very important event. So you can find more details on the internet, I guess. So CurrentOS today is working in many directions. We are pretty unique in the way that we not only describe a system, but we also describe the product, and we provide detailed specification to manufacturers to develop products. So I would say having a system description is a prerequisite in DC, because DC is not the same as AC, but also we go to the last mile to provide product specification. So we are working on this for converters, cables, protection, metering, digital, etc. So these are the part of the technical work in CurrentOS. We are also having a very close relationship with Open Compute Project, which is defining the data centers of the future. We have very close and more close relationship with other DC alliance in the world. China has one named PEDF. There is one that will be created in Korea. We have an existing one focused more on industrial applications in Germany named Open DC Alliance. And we have one in the USA named Emerge Alliance. So we are connected to these guys very quickly, with narrow communication, because we want to avoid divergence in the specification. We want to help the future business to take off with, I would say, similar specification. So this is a big objective of CurrentOS, to avoid, I would say, fragmentation and people going in every direction.
I see Lisa, Dr. Lisa T has joined us. Maybe we would like to have a few words about the upcoming conference. Please join with your mic if you would like. Turn on your mic if you would like. Yes.
Okay. Thank you. Thank you very much for promoting this international conference on DCMicrogrid. It's going to be held in Xi'an, as Yannick has mentioned. So it's going to be June next year, 2026. Also, at the same time at the conference, we are also going to organize some international DC organization global summit. So it's not being official yet, but I think we are expecting it's going to happen. I think CurrentOS is organizing this very important event. So thank you very much for promoting this conference. So if anyone wants to submit a paper, right now we are called for a 2-page digest. So if you're interested and want to join the conference, please visit our website, ictcm2026.com. You can submit a paper, and I think the registration link is going to be online at the beginning of next year. Thank you. Thank you very much.
Thank you, Lisa. Thank you very much.
Dr. Tong Cheng, would you like to have another word on Winline joining CurrentOS and your work with CurrentOS?
Yeah, I just want to maybe highlight it's like the CurrentOS is a really, really good organization, and then from there we not only get a lot of the newest technical information, but also the partnership, which is the most important thing. And then by this chance, I also want to do a small promotion for the CurrentOS plenary. It is a like every year, CurrentOS has 2 events, 2 plenary in different countries, and then hosted by different companies. And the next one will be in January in Portugal. And then all for this plenary, all the partners of the CurrentOS will come along and then meet offline. That is the best opportunity for all the partners to exchange what is the newest technology, and then what is the newest marketing information, and then the future trend of in the DC world. So I think this is the most valuable part for Winline for the last 2 years to join the CurrentOS. And then I'm sure like for all the new partners will also benefit joining this big family. Yeah, that's all. Thank you for today.
Thank you, everyone. Elan, would you like to have also a closing word before we end this session?
Yes, of course. I think, last week I was having some discussion with potential partners, And I truly agree with what Dr. Cheng just mentioned. Well, we're trying to create a full ecosystem for DC, and we are truly the early adopters. Well, not even early adopters. We are the innovators to the future for this full new innovation incubation idea of this new market. And so we have the chance to together work with CurrentOS to create the standard, to create the rules, and also create this new ecosystem, and everybody can play and can work together. And I was super touched. Tong actually mentioned about the plenary. I was in a US plenary session in the beginning last month, so beginning of October. And it was very touched, like everybody is there joining the plenary and share what's their innovation ideas and how to contribute in CurrentOS. Even though in mature business, we are sort of, competitors, friends, companies, but then for DC, we are really the partners. We're there to create this new market for DC to move to the future of electrical distribution, or for future HVAC, or for future lighting. So whatever industry you are in. So yes, let's join CurrentOS in this really open ecosystem and try to build a way to innovate together for the future.
Thank you for these closing words. So for sure, our next webinar will be related to electrical protection in LVDC microgrids. And thank you every one of our esteemed hosts for your support today in preparing this webinar and in answering to all the questions we had. Thank you to all the people who joined. We are very happy to see you so many today. And let's meet for the next one. In the meantime, you can meet us on currentos.com. The team is available, info@currentos.org, for any question, and we will be very happy to interact with any of you for any specific detail regarding your industry or your company, your organizations, universities or trade associations. We also welcome, of course, the test labs and the public entities as well. We are also very open to working on public projects. So see you soon. Thank you very much, and have a very good end of your day.
Thank you, Rafael. Thank you, everyone.
Thank you.
Thank you, everyone. Have a good day. Bye-bye.
Thank you.
Bye.